Good evening, everyone. And this is one more session with respect to Linux system programming. So, before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear as well as able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If you're able to recollect, what is the discussion happened in the last lecture? In the last lecture, we are trying to understand what is a PCB. We are trying to understand what is the difference, what is the meaning of context switch. We are trying to understand what is the meaning, what is the difference between the system calls and library functions. Will you agree? The system calls are the functions supported by system calls are the functions supported by an operating system, whereas library functions are supported by the compiler. Now tell me, when you open the man page, when you observe any function, how can you understand that is a system call or how can you understand that is a library function? How will you understand that is a system call? How will you understand that is a library function? Will you agree? 2 means that is a system call, 3 means that is a library function. Now, whenever a process is created, for every process, there is one data structure is created, one structure is created that is called as a PCB. This PCB is useful for doing the context switching. When the CPU is switching between the two processes, so suppose CPU switching between P1 to P2. So P2 previously how many instructions is executed? Now from where it need to execute, that information is present in this PCB. So this PCB loading and unloading takes place. Normally, context switch happens whenever a process time slice is expired. Will you agree? Normally, the context switching happen whenever a process time slice is expired. But there is a possibility before time slice expire also, before the time slice expire also, context switch happens. What is the reason? If the process left the CPU because of so many conditions like waiting for external event, delay, suspended or terminated, there is a chance that before the time slice expire also the process get the another process will get the CPU time to execute. So such type of discussion happened and we started working on one important concept that is called SYSTEM. And today our agenda is we need to understand these three things. One is a SYSTEM system, little bit more detailed. Second one, we need to talk about one function called very important function that is called P error. Third one, we need to talk about a fork system call. This fork system call discussion around 2 to 3 days we need to do it. Very important system call, fork system call. So today, let's once again start with a function called SYSTEM. Now, can you tell me SYSTEM, which is a library function or a system call? And I hope in the last lecture, I might have opened man page. I might have shown you SYSTEM is a library function or system call. Answer is it is a library function. It is not a OS supported function. It is not a OS supported function. It is a compiler supported function. Again, it is not a OS supported function. It is a compiler supported function. Is it clear? If you want, you can open the man page. You can find out. Now you tell me what is the argument I need to pass to the system function? What is the argument I need to pass to the system function? Can I say we need to pass string base address? Again, we need to pass string base address. That string should contain command. Will you agree? That string should contain the command. Huh? That string should contain the command. Basically, system function is used to execute the shell commands. Basically, system function is used to execute the shell commands. Now you tell me SYSTEM ls. Second situation is character S of 10 scanf percentile S comma S SYSTEM S. Now tell me, for this system function you are directly passing the command name compile time input. Will you agree? Compile time input. Can I say this is runtime input? Will you agree? SYSTEM ls, that is nothing but a compile time input. So compile time only you are deciding which command you need to execute. Next one is we are scanning the string and we are passing. Will you agree? This is the runtime input. If you accept this statement, type 2 in the chat box. One is a compile time input and another one is a runtime input. If you want, you can scan the command from the user that you can pass it. Can I say string name, string constant represents a base address? Will you agree? Try to think about the C program. String constant represents a base address. Array name represents a base address. Can I say in both cases we are passing the base addresses? In both cases we are passing the base addresses. Now very important thing we need to discuss about the system function. Now very important thing I need to talk about the system function. Observe. The system function allows that program to execute the shell commands. Again, the system function, this point already know, allows the calling program to execute the shell command. Example is this. Observe here, very important point. System executes a command specified in the brackets by calling /bin/sh-c command. Means whatever you are passing this string, that string is, this command is executed under which shell? That string, that command is executed under which shell? Under the sh shell. And upon failure it returns -1. Upon failure it returns -1. Now observe. Take this example. Consider this example. This is my C program. Now can you tell me, after compiling this program, we will get an executable file. After compiling this program, we will get an executable file. Suppose the name of the executable file is a.out. Tell me, after compiling this program, will you agree, we will get an executable file. Simply if we compile like this, so I'll get an executable file. The name of executable file is a.out. Okay. When I load this a.out into the RAM, for execution, can I say it becomes one process? It becomes one process. Suppose the process ID is Y. Now can you tell me who is a parent for this process? Can you tell me who is a parent for this process? Obviously, bash is a parent for this process. Now can you tell me, in this a.out process, how many instructions are there? In this a.out process, how many instructions are there? 3 instructions. What are those? First is a printf. What the printf will do? First is a printf. What the printf will do? Will you agree? This printf will print the data on the screen. Will you agree? This printf will print the data on the screen. Hello is printed. What is the second? System ls. Now observe, when you call system ls, internally 2 more processes are created. Very important. Now observe, whenever you call the system ls, whenever you execute a system function, whenever you call the system function. Now, can you tell me which function is calling system function? As a C programmer point of view, tell me who is calling a system function? Can I say main is calling the system function? Huh? So, as a process management point of view, if you think it, process Y is calling the system function. Again, as an operating system point of view, if you think it, process Y is calling the system function. Whenever a process Y calls the system function, internally, how many processes are created? Internally, how many processes are created? Two more processes. One is a SH, one is a the command which you supplied here. One is a SH and another one is the command which you supplied there. Now you need to tell me for this SH process, who is a parent? For this SH process, who is a parent? Y is the parent. For this LS process, who is the parent? Who is the parent process for LS? Who is the parent process for LS? Can I say SH is the parent process for LS? Who is a parent for this A dot out process? Who is a parent for this A dot out process? Bash. Now tell me how many processes involvement here, how many processes you are observing here. One is a bash. Under the bash you are typing /A dot out enter button. So this is the my pay process. For this parent is the bash, and in this you are calling the system. SH is created, LS is created. Process. What is the meaning of process? What is the meaning of process? Can I say a program which is loaded into the RAM for execution? What is the meaning of a process? Can I say program which is loaded into the RAM for execution? Process is nothing but a program which is loaded into the RAM for execution, that is called as a process. So here, whenever any process is calling the system function, will you agree internally two more processes are created? One more thing I need to tell you. When this high statement is printed, try to understand very important point. When this high statement is printed, can I say when this command execution is completed, then only this remaining statement below the system will execute. I need to ask you one very simple question. Whenever you use a scanf, after the scanf, what are the statements are there when it will execute? Whenever we use a scanf, after the scanf, whatever the statements we written, when it will execute, can I say when the user supplies the input, after that only it will execute? Similarly, whenever you are using a system function, below the system function, whatever the statements are there, these statements only it will execute when this command is completed. Again, below the statement, below the system, whatever the statements are there, those statements only it will execute when the command is completed. Again, below the system function, whatever the commands are there, whatever the statements are there, those statements are executed only the command which you supplied, only the command whatever you supplied here. Once that command is completed, then only the statements below the system will execute. If this point is clear, type C in the chat box. If this point is clear, type C in the chat box. Now here you may get a doubt. Sir, for bash, one PCB is created. For A dot out, one PCB is created. For SH, one PCB is created. For LS, one PCB is created. Answer is yes, because everything is one process. Everything is one program in execution. So separate PCBs are going to be created. Now, is this point is clear? This high statement is only it will print when ls command is completed. SH is a shell. Like how the bash is there, similarly sh is a shell. So this system, whenever you use a system, internally two more processes are created. Whatever the command you are passing into the sh, into the system, that command is executed under which shell? That command is executed under which shell? Under the sh. So sh is also one process. Who is a parent process for this sh? Who is the parent process for this sh? Our a dot out. One of the friend is asking why we needed two shells. That's what I'm saying you. This system function is internally implemented in such a way that internally it will create like that of things. Internally it will create like that. Is it clear? Let's take one more example. It will be more clear to you. Observe here. Now can you tell me in this program how many times I am calling the system function? In this program, how many times I am calling the system function? Two times. So this is the bash. This is our program. So first hello is printed. After printing the hello, system cal. Because of this system, one sh, under the sh cal. After the cal is completed, after the sh is completed, this will unblock the process. Next system will execute sh pwd. Now can you tell me how many processes involvement is there? 4, 5, 6. Will you agree? Here 6 processes involvement is there. 1, 2. 1 is a bash, which is a normal. 2 is our a dot out program, which we loaded. 3 is the sh. 4 is a cal. 5 is the sh. 6 is the pwd. Getting the point? So let's experiment one thing here. So if you use sh shell, then also two process. Anything, no matter your program is executing under bash or under sh. In this program, whenever you call system function, in this function definition, they implemented like this. In that function definition, they implemented like this. Is that clear? Okay. Now observe a very interesting point I need to tell you. Very interesting thing I need to tell you. vi p1.c. Okay. In this p1.c, hello world p1.c, PID is equals to percentile d, ppid is equals to percentile d slash n comma get PID and get ppid, and let's put my process is in a while one loop. Can you tell me what this program will do? Can you tell me what is this program will do? p1.c, it will print PID, it will print ppid, and my process is in, it will print PID, it will print ppid, my process is in infinite loop. Will you agree? My program is in infinite loop. Okay. Now what we'll do, I'll create a separate executable file for this. What I'll do now, cc p1.c -o p1. What is the name of the executable file? I need to include the header file. Which header file? In a double code, right? Header.h. Now observe cc p1.c -o p1. So will you agree? I created a separate executable file. Called p1. Now observe p2.c #include header.h void main printf in p2.c PID is equals to percentile d, PPID is equals to percentile d slash n, get PID, get PPID, and system dot slash p1 printf in p2.c by statement. Observe, in p2.c, will you agree, in a p2 we are trying to execute p1 file. In a p2 executable file, will you agree, we are trying to execute p1. In p2 we are trying to execute p1. Okay, now let me compile the code. -o p2. What is the executable file I created for p1? p1.c. p1 is an executable file. What is the executable file I created for p2? p2. In p2 we are trying to execute p1. I don't know you observed or not, p1 is an infinite. Will you agree? p1 is an infinite. Huh? Now I'll run dot slash p2. I'll run dot slash p2. First observe, in p2 is printed, in p2.c PID PPID, hello world in p1. Now can you tell me, in p2 by statement is not printed? Why? Can you tell me, in p2 by statement is not printed? Why? Because p1 is an infinite. Because p1 is an infinite. Will you agree? p1 is an infinite. The system function is blocking the process. The system function is blocking the process. Just a minute. I'll try to show you one thing here. cd linux _89 process management. Now tell me, ps-e. Observe, p2 is there. Who is a parent for p2? Can you tell me? p2 id is 288, 228. Who is a parent? This is my p2. For this parent is bash. For this parent is bash. In this p2, I am using system dot slash p1. Will you agree? In this p2, I am using system dot slash p1. Now, because of system, internally two more processes are created. What are those? Because of system, one is sh and another one is p1. One is sh and another one is a p1. Now can you tell me what is the p1 process ID? 230. Who is the parent for p1? 229. Who is 229 here? Who is 229 here? sh. Can you guess who is the parent for this sh? Can you tell me who is the parent for this sh? Not bash. Parent for this sh is our a.out, our p2 process. Who is the parent for p2? Who is the parent for p2? Bash. Now can I say, below this system function, whatever the printf I used, this printf is not executing because this system is blocking the process, this process. The system is blocking that process. Getting the point? Why the system is blocking? Because this command is not completing. This is an infinite loop. Because that command is not completed, because that is an infinite loop. Now can you tell me when this printf will print? When this command is completed, then only it will print. When this command is terminated, then only it will print. That is not going to terminate normally. That is not going to terminate normally because I used while one semicolon, so it will not terminate normally. Because I used while one semicolon, so it will not terminate normally. Because I used while one semicolon, so it will not terminate while normally. So what should I do? Press Control C here. Now observe, when you press Control C, this is terminated, the system will unblock. Below in P2 by statement is printed. When this is terminated, can I say bash is waiting for the user input? Will you agree? Bash, most of its time, it is in a waiting state only. Will you agree? Bash, most of its time, it is in a waiting state only. Sometimes it is waiting for user command to supply. Once the user is supplied, it is waiting for that command to complete. Again, once it is waiting for user to supply the command, once the user is supplied that command, it is waiting for that command to complete. Getting the point? So, what is the conclusion? Whenever any process is calling the system function, internally two more processes are created. Again, whenever any process is calling the system function, internally two more processes are created. Again, whenever you are calling the system function, internally two more processes are created. Now, one thing I need to ask you in this diagram, is this cal command and pwd command, are they executed concurrently or sequentially? One thing I need to ask you, in this cal command and pwd command, are they executed concurrently or sequentially? Answer is sequentially. Why? Because after completion of this cal command only, this function is called. If this command is not completed, suppose here /p1 if I write it, pwd command never executes because this is a blocking function. Understand? It is not a concurrent execution here. Here it is not a concurrent execution. After total completion of cal only, pwd will execute. Are you able to recollect what is the meaning of concurrent? Means if first is not completed, second should execute. Even the first process is not completed, second process should execute. That is a concurrent. Even the first process is not yet completed, second should execute. That is a concurrent. Sequential means after completion of a first process only, second process should execute. Now, after total completion of this, only pwd will execute. Suppose here cal is not there, here p1 is there, which is an infinity. Can I say pwd will never execute? Now you need to tell me, in one process, if you call multiple times system functions to execute the commands, those commands are executed concurrently or sequentially. Listen to this very carefully. In one process, in one program, if you call multiple times the system function to execute multiple commands, those are executed concurrently or sequentially. Answer is sequentially. After total completion of first command, second command will execute. After total completion of second command, third command will execute. If first command is not yet completed, if first command is an infinite, second command will not execute. So, When we use a system function, those commands are executed multiple times in one process. Those commands are executed sequentially. If this concept is clear, basically system function is used to execute the shell commands. One of the student is asking S15, sir, how P1 is executed in P2? That's what I'm telling you. That's what I'm talking you here. S15. Observe this P1.c. This is the code. I'll copy this code. I'll paste it here. So this is the program. So what is the can you tell me what is the executable file I created? What is the executable file I created for this? Just wait, don't answer everyone. S15, BE9, S15, can you tell me what is the executable file I created? BE9, S15, can you tell me what is the executable file I created for this? This P1 executable file. P1 executable file. Now, next program I written. Next program is vi p2.c. This is the next program. In this p2.c, I'm trying to execute that P1. In this P2.c, just a minute, it's not copied properly. In this P2.c, we are trying to execute P1. So just a minute. I'll try to. So for this executable file is P1. For this executable file is P2. Getting the point? S15. Now on the command prompt, I am writing /p. Can I say this instruction should execute? First it is printed. Next system./p1. So because we use the system in P2, can I say sh is created and P1 is executing here? Now you got an idea how P1 is executing input. Now you got an idea S15 how the P1 is executing P2. But in this P1, it is an infinite loop. That is the reason this command is not executing. This system is blocking because of process is an infinite loop. Because of that process is an infinite loop, it is blocking. Because of that process is an infinite loop, it is blocking. So when I terminate this forcefully by pressing Ctrl C, this is also terminated. When I terminate this forcefully because of this while one infinite is, then what happens? This system will unblock. Then this is printed. After that, bash is printed. S7, got the point? Bash is created our a.out, our P2. Who is a parent for P2? Bash. Under this P2, sh and P1 is created. Under that P2, sh and P1 is created. So it is actually bash. S7, are you there in the class? What is actually bash? Bash is a shell. Shell is a command interpreter. If you might have there in that class, you might have not asked. Can you tell me who is waiting for the input here? Who is waiting for the input? Who is waiting for the input? Who is asked that question? BE9S7. Bash. Bash is a shell. Shell is a Control C I typed to come out. Is it clear? Anybody having a doubt? If want to speak, please raise your hand so that I'll enable the voice so that you can speak. So system function is designed in such a way that internally it creates an SH. We can't change the definition of system function. We can't change the definition of system function. One of the student is asking, so why different type of shells are created? Why both times bash as such is not used? I need to tell you, shell is an application. So you have the Internet Explorer, Mozilla Firefox, and everything for browsing and internet. Similarly, operating system designers, different persons, they created their own shell. Is it clear? And bash shell, who is displaying this means bash shell. K8, these are the different applications. These are the different applications. Applications are not a mandatory, services are mandatory. So if one application is not there, bash is not there, I can use sh. Sh is not there, I use something else to communicate. And one more thing, if you're interested, after Linux system programming, you can create your own shells. How the predefined shells are there, after getting the total knowledge Linux system programming, you can implement your own shell. After pressing Ctrl C, P2 is terminated. That's what. After pressing Ctrl C, P1 is terminated because P1 is running at that moment. When I press, suppose here this is the bash, this is the P2, this is the SH, and this is P1. Can I say P1 is an infinite loop? So P1 is waiting. P1 is in a while one. When I press Ctrl C, so this is terminated. When that is terminated, this is also terminated. So this system will unblock. This system is unblocking. This will print. So when I press Ctrl C, this process is terminated because this is running in the foreground at that moment. That is running in the foreground at that moment. Got the point? BE8 P4. So my sincere request is, please raise your hand and speak so that I can easily understand your question instead of reading it. So after Control C, P2 need to, I hope I solved that. Sir, yes, sir, is it using SH since two bash processes cannot run? No, not like that. No, not like BE8N1, not like that. System function implementation is such a way that system function is implementation is in such a way that internally sh is created. BE9S is asking very interesting question, sir. Why we use system function? Answer is to execute the shell commands to create a process. S7, BE9 S7, to create a process, to execute the command, to perform one task. So in this program, what is responsibility of P1 file? M1. In this program, P2, I'm just for example purpose, I'm trying to tell you, in one program, another program you can execute. This is what. Got the point? M1, BE8 M1. In one program, if you want to execute another program or another command or anything, you can use system here. Yeah, anybody is having any doubt, please ask it. If doubt is more than 1-2 lines, please raise your hand so that I'll enable your voice so that you can speak. So that you can speak. But when we compile, we get BE8N3. I created a separate executable file ccp1.c-op1. I hope you might have forgot this command ccp2.c-op2. If you don't use this, by default a dot out. If you use like this, separate executable file. I created separately two separate executable files I created. Is that is clear? Still, my request is this is beginning only. Later, you should not feel difficulty of understanding it. So, my request is if you have any doubt, ask it. And my sincere request is rise and speak something regarding the things. If no doubt, we'll further move it. If no doubt, type 3 in the chat box. If no doubt, type 3 in the chat box. Just we are entering. There are so many things we need to learn. Many things on the basis of this only you need to understand. If this you didn't understood, remaining things is very difficult to understand. Clear? Next discussion is what is that? Next function is what is that? P error. P error function. Observe. To understand this P error, I need to create a program. After that, I'll not entertain the previous discussion. Again, I'm saying, if you have any doubt, ask it immediately. After once I started with the next discussion, if you ask me that questions related to the previous, I can't. Okay, now observe 3008 underscore 1 dot C header dot H void main. There's something related. This discussion first. Let's start with one file related concept. Again, now we are going to discuss about the P error function. Before entering into the error, let me create some situation. File related concept. File star fp. Fp is equals to fopen data file in a read mode. Can you tell me, upon success, what is the fopen returns? Upon failure, what fopen returns? Upon success, what fopen returns? Upon failure, what open returns? Upon success, fopen returns a file pointer, a structure pointer. Upon failure, it returns. Upon failure, it returns 0. Will you agree? Upon success, it returns a file pointer, structure pointer. Upon failure, it returns 0. Upon failure, it returns 0. If fp double equals to 0, so normally what we will write? Printf file not present, file not found, return. If fp double equals to 0, file not present, return. Printf file present. Printf file present. If fp double equals to 0, I am displaying file not present. Okay. Now let me compile the code. CC3008. Just a minute. Just it is get struck up. Please wait. Please wait. Now tell me, in the present working directory, is there any file called DATA? In a present working directory, is there any file called DATA? Answer is no. So now tell me, when I write /a out, file not present. Any doubt in this? This is just simple old discussion only, previous discussion only. Now if I create data, if I create some file, now you tell me in the present working directory, file is there or not? Yes. Now execute, file is present. Now observe chmod u minus r data. What is that chmod? Don't worry right now. Those who already know, don't worry. Those who don't know, don't worry. Once we started with the file handling, we'll discuss it. Chmod is useful for change the permission. In a single line, if I say chmod is a command to change the file permissions. Chmod is one command to change the file permissions. Okay. Now you tell me, in the present working directory, data file is there or not? In the present working directory, data file is there or not? Yes or no? There. Now when I run it, file not present. Can I say here open is failed there? Even though file is there, fopen is failed there. Now why fopen is failed? Why fopen is returning 0 in this case? Can anybody tell me? Why fopen is 0? It is failing. Why fopen is it is failing? Answer is, we are trying to open the file in the read mode, but the file doesn't have the read permission. Again, why fopen is failed here? Very simple. Which is the file permission? File doesn't have the read permission. File doesn't have the read permission. But we are trying to open in the read mode. But what it is showing? Can I say this printf, if I write like this, it is misguiding us. This printf, if I write like this, will you agree it is misguiding us? We are thinking file is not present, but actually file is not present. Means can I say this fopen is failed because of something else reason? Fopen is failed not because of file not present. Fopen is failed because of file doesn't have permission. Open it. Read permission is not there. But we are trying to open it in the read mode. Read permission is not there. But we are trying to open it in the read mode. Because of file not present, not failed. Because of permission is not there, it is failed. So what I need to do is, there are so many reasons. What I need to tell you is, there are so many reasons fopen may fail. Again, there are so many reasons fopen may fail. Reason number 1, file may not present. Reason number 2, file may present but. Reason number 2, file may present but. File may present but what? Read permission might have not there. Reason number 3, the hard disk may be full. Suppose you are trying to open the file in the write mode. I don't know how many of you remembered or not. In a write mode, if the file is not there, it will create a file. In a write mode, if the file is not there, it will create the file. But suppose file doesn't have the permission. Suppose file hard disk is full. We can't create a new file. Suppose the path, whatever we mentioned here, the path may be wrong. I don't know how many of you are able to recollect it. How many of you are able to recollect it? The first argument, we need to supply the path. If you don't supply the path, it will consider as, if you don't supply the path, it will consider as, if you don't supply the path, only the file name, then it will consider as present working directory. Suppose you might have given the wrong path there. Again, suppose you might have given the wrong path there. Suppose the file may not present. Suppose the hard disk is full. Suppose the permission is denied. So can I say there are so many reasons fopen will fail. Whatever may be the reason for the failure, what fopen returns to you? Whatever may be reasons for the failure, what fopen will return to you? Can I say fopen, whatever may be the reason for the failure, fopen returns a 0. If you want to print the reason for the failure, don't use p error, don't use printf, use p error. Again, if you want to use, if you want to know the reason for the failure, so don't use printf, use p error. If you want to know the reason for the failure, don't use printf, simply print file not present, use p error now. Now observe, when I use p error, see, file is there but permission is denied. Now tell me, when any function is failed, better to use p error or better to use printf, just display? Better to use p error to print the proper error message. Better to use p error to print the proper error message. Now you tell me, I'll remove this file. Now if I execute, so why fopen is failed now? Previously permission is denied. Now why fopen is failed? Now why fopen is failed? Can I say no such file directory? Why fopen is failed here? Will you agree? No such file or directory. So from now onwards, the better approach is whenever any function is failed, use a p error. If the function is success, p error will print success message, success. Again, if suppose the function is success, still you are printing it. If suppose function is success, still you are using the p error, so it will print success message. In a p error, anything you can write, any string you can write here. In a p error, anything you can write it here, just to our understanding purpose. Anything you can write. It's not a rule that it must and should be capital letter. Anything, any one string. Better approach is the string should be name of the function so that you can easily debug it in a future. Better approach is the string should be the name of the function so that in future you can easily debug it. Very interesting, right? So one function is failed, other function is saying that you failed because of one reason. Again, one function is failed, other function is saying that this function is failed because of this reason. Now the question arises, I don't know how many of you got. Now the question arises, sir, how this function knows that function is failed because of this reason? Try to understand. How p error knows that, how the p error knows that fopen is failed because of which reason? How the p error knows that fopen is failed because of what reason? So for that, you need to understand one internal concept, what happening internally. I need to talk about one variable, that is ERRNO, error number. Again, I need to talk about one variable which even though we didn't declare it, for every process this variable will be there. Even though we didn't declare it, for every process one variable will be there, that is ERRNO. That is ERRNO. So man ERRNO error number. Observe here, the ERRNO.h is a header file, defines the integer variable ERRNO, which is set by system calls and some library functions in the event of error indicates what went wrong. Suppose this is my process. This is another process. For every process, there is one variable is created, ERRNO. Suppose if this process is calling fopen function, what fopen function will do? Upon failure, it will set this error number here. Again, suppose this process is calling fopen. Fopen, what it will do is, it will set the error number into this particular process. So who will set this number? Which is set by a system calls and some library functions in the event of an error to indicate what went wrong. Means for every error, there is one number will be there, specific number will be there. Now tell me, if this process might have calling fopen, okay, fopen will set this process error number. Now in this example, how many processes I taken? In this example diagram, how many processes? 2 processes. For every process, there is a separate ERRNO will be there. One thing I need to tell you, immediately after this function call, you need to print that error number. You need to display the proper error message. Suppose if I am using fopen, after that if I am using any system function, if I print p error here, which error message is displayed? Will it fopen function or this second function which you called? Second function. So immediately after that function call, if you want to print the error message, immediately you need to use p error. Again, the ERRNO.h is a header file, defines the integer variable called ERRNO, which is set by system calls and some library functions in the event of error to indicate what went wrong. So immediately after that system call or after that library function, you need to use p error. For every process, this ERRNO is now system error messages. I'll show you. All of you are observing these macros. E too big, argument list is too long. ESCCES, permission is denied. Like this, all these are the system errors. All these are the system errors. So the respected functions depends upon the error internally. It will set this ERRNO of that particular process. All these are macros. If you want, you can print the numbers. These are the numbers actually. All these are the macros. But if you want, you can use a %ILD. See, no such process and too many. Where is a no such file or directory? Is there any? Have you observed anywhere no such file or directory? Have you observed anywhere no such file or directory? $300. Is it at 300 line? Somewhere you will observe no such file or directory, no device. Just a minute. So these are the all the system errors. Any function is failed means in this may be one of the reason. No such file or directory. All of you are getting this point. So how many system calls are there? And some of the library functions, if anything wrong happens, so then they will set the error number. By this p error will see that error number. P error will see this error number. It will display the error message. P error will see this error number. It will maintain a lookup table, and according to the number, the message it will display. BE9K2, sir, is P error used only for files? P error not only for files, any system call also you can see. We can use P error after system also. So to know that, you need to open man fopen. Observe, I'll show you one interesting point about it. I opened fopen function. Where is that? Upon failure, return value. Observe. Fopen as an example I taken. Fopen upon success completion, fopen returns a file pointer. Otherwise, null is returned. And all of you are observing this. And ERRNO is set to indicate the error. And ERRNO is set to indicate the error. So open the man page of SYSTEM and check the return value. Will it set the error or not? You can find out. Again, BE9D3 got the point. Open the man page of SYSTEM and check the return value, and it will find out this SYSTEM will set the error number or not. So from now onwards, any functions in a system programming, especially in a system programming, from now onwards, if you want to know the proper error message, because of what reason this function is failed, instead of writing printf fail, we need to use proper error message immediately after the function call. Immediately after the function call, you need to use. Getting the point? And I hope a system will not print that. Say system will not set that error number. But there are so many functions in future we are going to discuss where system calls upon failure they will set an error number. One more thing I need to tell you. System calls, almost all 19.9% of system calls, upon failure it will return -1. Again, 99.9% of the system calls, upon failure it will return -1. I'll open man to open. 2 means system call, right? This is an open system call. Now observe, maybe in the down, these are the macros. In here we need to discuss. Open system call. Return value. See, open system call returns a new file descriptor or -1 on error in case error number is set appropriately. Means almost all the system calls will set an error number, but library functions, you need to open the man page, you need to observe it. So for debugging purpose, this SYSTEM will help us a lot. So I am the process, you are also one process. Suppose there are two processes are there. If this process is calling the fopen, so can I say this process ERRNO is setted. If this process is calling the fopen, that process ERRNO. Don't worry about child is not created, DE9, D3. So what is the meaning of child is created and all other things? So once we started with the fork system call, we'll discuss it. Next discussion is that only. Fork system call to create a duplicate process, to create a child process. Is that point is clear? Today's important points are, first point is, what is the first point? When we use a system function, the system function is a blocking function. Will you agree? When we use a system function in my process to execute one command, whatever the command you supplied in this, until and unless this command is not yet completed, remaining statements below the system will not execute. Is this point is clear? Second highlight is p error function. Instead of displaying the error message printf error, instead of displaying the error message printf err, printf some what you call error message, use p error to display the proper error message. Use p error function to display the proper error message. If these 2 points are clear, type C, so that we'll move to the next discussion. Very important discussion, that is fork system call. That is a fork system call. Now, who will set the ERRNO? Can you tell me who will set the ERRNO? Who will set the ERRNO? The functions which we are calling. Observe, the p error function produces a message on the standard error describing the last error encountered during the call to a system or a library function. One of the student is asking where the ERRNO is saved in a dot out. ERRNO is one global variable. You need to say where. ERRNO is one global variable, one integer, global, where it is stored. Can I say data section of that particular process? ERRNO is one integer variable which is a global, which is, you will not see that. Without knowledge of you, internally so many variables are declared. In that, this is one of the variable. B9S4 got the point. I hope you know global variables are stored in a data section. One more important point I need to tell you, how this ERRNO, observe, after the message whatever I passed, that is printed. Will you agree? Colon is printed. After that, one space. After that, the proper error message. After that, the cursor goes to the next line. Observe here. Observe this PPT here. Here it is mentioned. First, whatever we are passing in this string p error, it will printed. Followed by colon and one blank space. Then an error message corresponding to the current value of the error number and a new line also. Will you agree? In my p error function, I didn't use this colon. If I open this program, if I show you, just I used ABCD, right? This ABCD is printed. After that, colon is printed. After that, space. After that, the error message. After that, new line. Is it clear? So that colon, space, new line, we are not given. Just so, what is the proper statement here? Can you tell me what is the proper statement string we need to pass here? What is the proper string we need to pass? The function name which you are displaying, which error? The function name. For which function the error? Now you tell me, I am calling first one system call, second I am calling the second system call. If I use p error, will it print first system call error message or second system call? Second system call. Suppose if you want to print first system error message, first function error message, after the first function, immediately you need to call p error. After the first function, immediately you need to call the p error. Is it clear? Huh? So from now onwards, make an habit. When a function is failed, don't use. When a function is failed, don't use. What is that? Don't use printf error. Use p error. Is clear? Okay. Next session, what we'll do is we'll stop the today's session. Next, that is fork system call. We'll discuss in a tomorrow's session. Is it clear? Fork system call tomorrow session. Any questions? One question came. May read. Sir, we need to call p error below the or after the function called. That's what. After any function call, below that use p error. In between, don't call any other functions. S9 got the. If in between, if you call any other function, maybe this error message you will get. You will not get this error message. First error message. It's clear? Okay then. I'm going to wind up the today's session. I'll upload this. If it is a success also, you can use. If it is a success also, you can print. It will print SUCCESS, success message. Is it clear? If in a success also, you can print it. It's not the meaning that only failure you need to. But for every function, success, it will print only success. Okay. Thank you very much. So can we user-defined function to set an error variable? Yes, if you want, one of the student is asking very interesting. Sir, can we user-defined functions to set an error number? You can print ERRNO also. You can print ERRNO also. In your functions also, you can set that error number. When you are designing your own functions also, if you want, you can print, you can set the error number. R3 is asking one question. Sir, here we are using the bash in form of an application in a Windows or Linux or OS. B8 R3, I'm not getting your question. Please raise your hand so that I'll enable your voice so that you speak. B8 R3, I'm unable to understand your question. Please raise your hand. I'll enable your voice so that you can speak. Yeah, good evening.
Sir, good evening, sir. Sir, actually, are we using?
Just a minute.
Okay.
Yeah, tell me.
Sir, we are using Ubuntu application, right, sir?
This Ubuntu application is a subsystem in a Windows.
Sir,
yeah.
Yes, sir, is it a OS or only?
It is a OS. It is a OS. Okay. In this OS, applications are not there. Only bash is there. Remaining applications are not there. In a normal Ubuntu, in our lab or somewhere, the different applications are there. This is a OS which contains only the shells.
Okay.
Got the point? That means GUI is not there for this Ubuntu. Only command. Got the point?
Yes, sir.
Okay.
Thank you. So Ubuntu this is the application. In this application, only command interface they given. Command interface means shell equal B9A8. Got the point? So this is a subsystem. Subsystem means this is the Windows OS. So this is a subsystem, like an app. We are using it. Otherwise, VirtualBox, otherwise dual booting, like this we need. Okay, then I'm going to wind up the today's session. Thank you very much.